Alright guys, in this video we're going to talk about the secant graph, and what we'll probably do here is honestly just kind of talk about the secant graph, and then this cosecant graph is very similar, just slightly different placement, and because it comes from our other sinusoids. So the secant graph comes from the cosine graph. It is the reciprocal of cosine. And so when we go to find these values, we're going to go look at our unit circle and then take the cosine values and then flip them. So if you're going to do the cosecant graph, it does work the same way except for sine. So just bear that in mind as we're going through all of this. Y'all look here at our table. So I'm going to go again, our unit circle. And I'm going to look at pi over 6, look at your x coordinate here, and we're going to take that and flip it. So this is going to be 2 over the square root of 3. We're going to just do the same thing. I'm not going to keep bringing the unit circle back and forth. Y'all keep that handy so that you're able to look at those values. For pi over 4, we should end up having the cosine is square root 2 over 2. Or if you looked at it before it was rationalized, that was just the 1 over the square root of 2. So if I flip that, it's just going to be square root of 2. And then pi over 3, if I take that and flip it, the cosine value is 1 over 2. Flip it is just 2. And then pi over 2, the cosine value is 0. 1 over 0 is undefined, right? So y'all pause the video, go ahead, fill in the rest of these two tables, just like we've done with our last ones, and then come back when you're ready to check that and try graphing, all right? Okay, these other values we should have gotten are -2, -1 over square root of 2, -2 over square root of 3, and then -1. Down here, these values, they don't 100% repeat from the ones above, so you got to watch out. This is going to be a -2 over square root of 3. This is -1 over square root of 2. This is -2, undefined. Then we get our positives. This should be 1 over square root of 2. Then this guy, 2 over square root of 3, 1. Again, you can rationalize those denominators. I usually do, but just because of the sake of graphing these, it's going to be a little easier just to change them actually to decimals instead. This guy's about 1.2. This one's about 1.4. And those are really the only two decimals you're going to need. They just become positive or negative. All right, let's graph and see what this is going to look like. All right, so at pi over 6, we're supposed to be at about 1.2. So I'm going to say we're about in here. At pi over 4, remember that's between these two lines. Pi over 4 is supposed to be at 1.4-ish, so around in there maybe. And then at pi over 3, we're supposed to be at the value of 2. At pi over 2, it's undefined. And if you guys remember from before, what that really indicates is it indicates that asymptote. So when you see that undefined value, that's what we're going to have. Okay. Keep on going. 2 pi over 3, we're supposed to be at -2. What? Then we're supposed to be at, again, this is as a decimal, this is going to be about -1.4. No, I'm lying. Hold on. Pause, y'all. I've lost my mind a little bit. When we flipped these, okay, if you thought I was going crazy, I was. Here's what I was doing is on my paper I have over on this side, I rationalized the denominators, and I was looking at a combination of that and trying not to rationalize them, so I'm sorry. This guy, when you flipped it, it should have been negative square root of 2. Same deal with this one. That is my bad, I'm sorry. Like I said, I was trying to unrationalize the denominators from my paper that I have over on this side over here. And I was doing that in my head really quick, and I did it funky. Okay, those values. All right, now again, this should have been negative 1.4-ish. This guy should be about negative 1.2-ish. Okay, and then from there. I'm sorry, that's my bad. All right, we're going to go back here between the 2 pi over 3 and the 5 pi over 6. That's where the 3 pi over 4 will be. And we're going to take that down to about 1.4. So down in here. Then we're going to look at the 5 pi over 6 and 1.2. And then we're going to be at pi negative 1. All right. Then we're going to go to our next thing, which is on the bottom table, 7 pi over 6. That's on this line in here. Again, that's going to be that 1.2-ish down here. Then we're going to get to that pi over 4 deal, and that's going to be around in here. And then 4 pi over 3 brings me to negative 2, so that's a little bit of a bigger jump. We're kind of seeing, we're kind of seeing this curve downwards situation. Looks a little bit like a parabola there. Okay. Then we have at 3 pi over 2, we end up with another asymptote. So draw that in there. Okay. Then this is going to jump back up and be positive. So at 5 pi over 3, we're going to be up at positive 2. At 7 pi over 4, we're going to be at that 1.4 value. So about in here-ish. At 11 pi over 6, we're going to be at about 1.2-ish. And then at 2 pi, we're supposed to be at 0. So we kind of end up with this odd behavior here. Now, another one, again, is if I had looked at what's going on at 0, the output on that should have been a 1. And so I can look back here and see where that would have been, right? So you kind of get this curved upward behavior there. We get this one here where it curves both sides down. And then we have this one here that curves that way. And I want you to imagine if I took this guy and I copied it over here, that's going to curve back up, okay? So really we just get these alternating values where they curve up, curve down, curve up, curve down. All right. Now, one thing that really clicked this into place for me when I was learning this stuff back in the day, I know it's been a minute. I'm going to finish this one out really quick just because I think it makes it easier. But back in the day when I was y'all's age going through this class, what really made this start clicking for me is to see this side by side with the cosine function. Cosine, because that's the one that's the reciprocal of it. So I want you to look at what cosine looks like, okay? Cosine, I'm going to put that here in this other color, okay? So here I am going to do cosine in this yellow color. I know it's not very bright, but that's on purpose. I don't want it to be super prevalent here because really we're studying the secant graph, okay? Green is secant. Yellow is going to be what cosine looks like. So compare to what you know cosine is. Cosine on the y-axis goes through the value 1. And then at pi over 2, it goes through 0. So I want you to see what's going on here. Remember, it makes this wavy pattern. Then at pi, it hits negative 1, bounces back up, hits 0, bounces back up. Y'all see that? It goes through that kind of pattern. So you can see those side by side. As you look at cosine, this guy hits that maximum and bounces away. This one hits the minimum and bounces away. And it will do that forever and eternity. Everywhere where the cosine graph hits the x-axis, that's where the asymptote lives on the secant graph. And we have similar relationships when you look at sine compared to cosecant. So again, I don't feel like I need to repeat all of that just for the new graph, but I just, I think it's important to kind of see those side by side. I think it makes it a little easier to understand where it comes from. All right, so we look at cycles, right? A whole cycle of this thing It's not just from asymptote to asymptote, okay? Because that you're seeing that curve down behavior right there, but that didn't include the whole other part. So you have to go from like the beginning of what we graphed to the end of what we graphed together before that repeats itself again. And so that's a total of 2 pi, just like the period for cosine. All right. Does it have a minimum or a maximum point? No. Therefore, there is no amplitude. Okay. And this graph, again, it continues forever and always in both directions. So we're going to put this little packet thingy away, keep it to where it's something you can reference. And again, if you're wanting just for fun to discover that cosecant graph on your own, then definitely take the time on your own to go and see where the cosecant graph comes from, compare that to your sine function, and you'll see the exact same type of relationship. Okay? All right, we're going to spend the rest of our time looking at our handwritten notes. So let's look down here. This is your secant function in your handwritten notes. So I want you guys to make sure that you get that on here. I did go ahead and I compared it to what that cosine graph looks like. You can see the asymptotes in here where they're hitting the pi over 2s. Odd values of pi over 2 is where those asymptotes are. And again, that's just where cosine hits the x-axis. So the yellow in here is your cosine graph. And this blue is the actual secant function. So that's my color coding over there on the side. I just wanted us to see those and how they relate to each other because it's a pretty cool comparison, I think. When you graph the secant function, you don't include graphing the cosine. So that is just there for our reference so you can kind of see how they compare, right? The only thing you'd have are those little u's going up, going down, and those asymptotes. All right, let's try a problem. So when it comes to solving problems, we've talked about transformations. I think we've kind of just kind of done that almost too much. So we're going to try a different type of question here. You're going to see questions like this on your assignment as well, so it does not hurt us to talk about it. There's actually multiple ways that we can get this, the answer to this. They said we're going to find the value of x between pi and 3 pi over 2. That's important to look at that interval, okay? And that we want it to solve the equation that secant equals -2. Now, let's talk about how this would work, okay? Because there are multiple ways to do this, but one thing that's really, really, really important because there are technically infinite answers. So, there's 2 on the unit circle itself, but if you look at coterminal angles, there's infinite answers. So what I want you to visualize is if they say it's between pi and 3 pi over 2, here's pi, here's 3 pi over 2, meaning we want it to be in this quadrant, okay? They're limiting us to looking at something in this quadrant. Now, if you are the type where you've memorized your unit circle and you are like set, then it's going to make it a little bit quicker, but this is not the only way to do it. So I just want to throw that out there. Okay. What I do need you to remember is that secant is the same thing as 1 over cosine. So if I'm looking at secant of x equals -2, you can also compare that. Lord have mercy, my whiteout's not working. You can also compare that to 1 over cosine. Same thing. Okay. So what I could do is I could look at this and say, well, if 1 over cosine of x is -2, cosine of x is going to be -1 over 2. If you flip both of those, then you can see what cosine is. And that way x is not in the denominator anymore. Now we have talked about how you can solve this. You can use your inverse functions. If you've got a calculator, that might make that easy. But if you don't, just ask yourself, where is cosine x equal to -1 over 2 in this quadrant? Okay, so you could then reference your unit circle, say in this quadrant down here, where is my x, -1 over 2? That's here at 4 pi over 3. So x would be 4 pi over 3. Okay. Now, if that is not for you and you prefer looking at your triangles, your alternative method would be like, okay, well, cosine is -1/2. Let me look. If I were to draw something here where I was looking at 1/2, here's my angle. Just draw an arbitrary angle in here. Here's x. And I need cosine adjacent over hypotenuse. Adjacent over hypotenuse. So this guy would be 2. Adjacent would be that 1, right? And you could then be like, what angle would it be on that special right triangle that has this relationship? Remember how we have that 30, 60, 90 triangle? We have the short side is 1, the hypotenuse is 2, this side is square root of 3, but this angle right here is a 60-degree angle. And so you can say 180 degrees plus 60 degrees makes 140 degrees, which is the same, 240 degrees, which is the same as 4 pi over 3. So, and they didn't say it had to be in radians or degrees. Either one of those is okay, but keep in mind, AP class, that you only work in radians. So as far as your AP test goes, so that's important to note. Anyways, multiple choices as to how you could get that answer. One is to look at special triangles. The other is to be able to just really know from your unit circle where that would be. Okay. All right. And we, last but not least, have some notes on our cosecant function. I told you it looks very much like the secant function. It's kind of shifted over, but just like sine and cosine, they're related that way. Secant and cosecant are too. So you can see here what the cosecant function looks like compared to sine. Sine is what you see in that yellow. So it's not very bright, but that's on purpose, because the cosecant function is what we're studying. So when I ask you to graph cosecant, you're graphing me those u's with the asymptotes, not the sine function. I just like it. I like to see those side by side because I think they're pretty. All right, and our last example here, and then we are done. Our last example, they said find the smallest positive number x such that x squared equals cosecant of x. And you guys are going to love this. This is one of those rare moments where I'm going to say this is a calculator question. All right. So I'm going to say grab a calculator and make sure I've got the brightness. Nope, I don't have it turned down here. Let me fix that. Here we go. What we're going to do is on your calculator, we're going to look where do they intersect. So the first thing we're going to do is say, okay, let's open an equation here, a function, and I'm going to enter the first one, the one on the left. Just put x squared, okay. Then on my next one, we're going to put the cosecant function. You might be thinking, where is that? Okay, well, I will show you. Let's zoom us in a little bit, okay? So for the second one, I want the right side of that equation. I want the cosecant function. We're going to open up your suitcase. So y'all see where that paste button is down here at the suitcase. Click on that one. Okay. And then we are going to, hold on. We're going to scroll down until you see the trigonometry. We're going to click on advanced. And there it is, cosecant of x. We're going to have to input the x. So don't assume it's there, but hit OK. And now we have our two things. Go up to graph, OK, and we're going to see those guys. Now, these hit in multiple places. What we want is we want the smallest positive. Remember that? Smallest positive number where that's the case. Meaning I want to see this one right here. Where do they cross? Right in there. Okay. We're going to go to the calculate screen. We're going to just click on one of them, say find intersection. I don't want that one. I want this one. And where they intersect here, that x value is 1.068. That's our answer. Okay, so you would just tell me x equals 1.068. That's it. So those types of questions are nice, simple, and quick to work. All right, that is it, guys, for this 4.5 lesson. Thanks for sticking with me through all of this, and I will see you all in the next one. Bye.